Ever since I can remember, I've been interested in thinking about the stars and thinking about the universe and how it's put together. As a blind person, my in for knowing about that was to read science fiction or to watch space documentaries on TV.
You are about to take a journey out of this world.
When a sighted person looks up at the night sky, there's a visceral connection, I think, that people feel to the universe around us. For me, sonifications are the way that I get to have that visceral sensory experience of the universe. Sonifications are life-changing for me. I get to have that experience of the universe.
Listen to the universe. Data sonification in its simplest form is just the translation of information that we can see into something that we can hear. It's this idea of extrapolating out that information into sound. My name is Kimberly Arcan, and I'm a visualization scientist and emerging tech lead for NASA's Chandra X Observatory. All that means is that I get to take data from our universe and tell a scientific story with it. In this case, I'm sticking with my good friend Cassiopeia A, this beautiful exploded star. And what we've done is we've used the sliced data with the silicon, the sulfur, the calcium, the iron, and the high energy, and mapped each different layer to a different sound, a different tone. We worked with people who are blind or low vision to make sure that they could extrapolate their own meaning. If you are just listening to this object, that the scientific story would still be communicated in a way that made sense and that was also pleasing. And then we test again, because we don't want anything that's going to hurt people's eardrums, not make sense. If it's too fast, for example, if it's too slow. But it is like when you're making images, there's, choices to be made.
Sonification is important because it gives us a different way to experience and perceive information. In particular, it's very important for people who are blind or visually impaired because it gives them access to information they wouldn't otherwise have. So the idea is to convert relations or features in data into something we can hear, like the changing pitch of a note or the changing volume. It turns out that it's not just people who are blind or visually impaired that find value and meaning in these sonifications. They're popular almost universally with the general public. And perhaps that's because they help people connect something that's far away and unfamiliar in astronomy with something that's deeply personal and emotional, such as music.
So with all of this type of data that we're getting from these various NASA telescopes, we have to translate it from something humans can't easily, naturally detect into something we can
either see or hear or even perhaps touch. So it's this process of translating information from one form to another. And when we're doing that, we can create a visualization, or we can create a sound, or we can create something that could be 3D printed, for example, so that we could touch it. But it's kind of the idea of, if you're speaking French and you need to translate into Mandarin, you're just taking that information and you're just moving it into another form. So it's just another way of understanding.
For me, the process of getting to know a sonification is it's demanding and rewarding, and it takes time, because instead of just looking at an image and maybe reading a caption and then listening, I want to read through what each sound means. The way the sound is panned gives a lovely sweeping sense that the image is big, or at least what the image is referencing is big. And so this one is very rich. The listening experience, even if you just listen to it not knowing what it was, it's a lovely, lingering, meandering sort of melodic listening experience. And then when you add in the meanings, it becomes so much richer and more meaningful, more important.
Most of what we're looking at in the universe is in a light or type of light that humans can't naturally detect. I like to think of these telescopes that are up in space as just being, kind of super friends, right, with their various superpowers. And Chandra's superpower is to look at really energetic regions, really hot regions of space. But what's really helpful is to be able to look at the entire universe with a different set of eyes, looking at many different kinds of light. So for example, though Chandra looks in X-ray light, there are other telescopes that look in infrared light, like the James Webb Space Telescope or the recently retired Spitzer Space Telescopes. Hubble looks at optical light and also little bits of ultraviolet and infrared light as well. There are radio telescopes, gamma ray telescopes, and the whole point is you need all of these different kinds of telescopes to be able to fit in the various pieces of the puzzle. The Perseus cluster of galaxies is this beautiful system hundreds of millions of light years away from us, where it's a cluster of galaxies that has a very high-powered, supermassive black hole at its core. And what Chandra found back in 2003 was that that black hole is essentially burping out into the hot gas around it. And what that burping into the hot gas is doing is causing pressure waves, which are sound waves.